Do y'all remember that song? You might be too young, but it was like, this is the song that never ends. You know, it goes on and on, my friends, blah, blah, blah. This is the worksheet that never ends, y'all. Okay, we are on topic 9. Okay, so topic 9 is the rows. Okay, so this is another polar equation. It has a very specific type of graph. Okay, this is another situation like all of the, like the cardioid, the limacon, or the limacon, however you want to say it, the rows, and then what we're going to do next. They're their rectangular versions wouldn't like it wouldn't fly for us. So we need these polar equations and they create such beautiful graphs. Okay. The rows is potentially my favorite, we'll say. Number one, I can pronounce it. Number two, it's just so daggum cute. And I remember doing stuff with these at some point many years ago. I don't remember what, but anyway, they're just so cute. So anyway, the format for the equation, remember all of these equations kind of have like a template. Okay, so in this case, you're going to get R equals A times cosine of n times theta. And then you can also get R equals A times sine of n times theta. We have a couple of conditions. A cannot be 0, so A could be anything but 0. And then when it comes to the n is going to tell us about the petals. Okay, so you can see this graph I have to the right clearly has 4 petals. Okay. So the n value is our secret to how many petals we're going to have, okay? So if n is not equal to 0 and is even, then we're going to have n times 2 petals. So whatever n is, double it, that's going to tell you how many petals you're going to have, okay? If n is not plus or minus 1 and it's odd, then you're going to have just n petals. So whatever n is, that's going to be the number of petals you have, okay? So let's look at a graph, one with cosine, one with sine. Okay, and let's see what we have here. So just make sure they fit the criteria, the template here. So we have R equals, well, in this case, we have 3 times cosine of 2 theta. So we have A equals 3. We're good. It's not 0. And we have N equals 2. Okay, so we definitely fit the criteria. We have the format for a rows. And then for the second equation, we have R equals 2 times sine of 3 theta. So in this case, A is 2, which is great as long as it's not 0. And then we have N equals 3. Okay, so both of these fit the template. We definitely have the equation for a rows. So let's go to the calculator and just kind of get a quick idea of what's going on here. Okay, so make sure again you're in polar mode, radians mode, and then we're going to go to y equals. Okay, so when I go to y equals, I want to type in 3 times cosine of 2 theta. Okay. And before I hit graph, let's talk about what we think is going to happen. Now, we know that if n is even, we're going to get, as long as it's not 0 and n is even, we're going to get 2 times n petals. So in this case, n is 2, it's even. That means we're going to get 2 times 2 or 4 petals. Okay. So kind of brace yourself for that. Okay. Isn't she cute? Okay, now let's change our window a little bit. Let's go maybe, is it 5? I think 5 will do here. So let's go -5, +5, -5, +5. We'll see what that looks like. And it's a little off. You can tell it's a little like, So let's see what happens if we do zoom squared. It may change my window way too much. No, it's perfect. We like it. Okay. So we have our 4 petals. They definitely go through the pole here. Okay. And each petal goes up 1, 2, 3, down 1, 2, 3, to the left 1, 2, 3, to the right 1, 2, 3. So these are a little bit easier to draw in my opinion. Okay. So we definitely have some symmetry happening here. Um, we have symmetry with respect to the polar axis. We have symmetry with respect to the like y-axis or the pi over 2, okay? And symmetry with respect to the origin. All right, let's go back to, there it is. Okay, so let's draw this. Now we have A equals 3. That's important. And then we have the n equals 2, which told us that we're going to get 2 times n equals 4 petals. And we did. And our petals are wrapped around the XY axes, okay? Or the pi over 2 polar axis, whatever you want to call it. I don't care. So 1, 2, 3. One, two, three, one, two, three, one, two, three. And we go like this. Whoops, got a little wacky there. So there you have it. Okay, that is pitiful. Now that I look at it without my big old hand in the way, it's awful. Let's try again. That's a little bit better. Okay, so there is our rose. Okay, let's go back. Well, let's first decide how many petals we think we're going to get. So we have R equals 2 sine of 3 theta. So we know A is 2. Okay, and then we know N equals 3. And remember, as long as N isn't 1 or -1 and N is odd, that tells us exactly how many petals we're going to have. So in this case, we should get 3 petals. So let's see. Let's go to the calculator. That's not the calculator, y'all. That is. Okay, so let's go to y equals, we want to clear out the old equation. This time we want to type in 2 times sine of 3 theta. Okay, we're expecting 3 petals. Let's see what we get. Fingers crossed. 3 petals. Okay, so this one is a little scrunched. Let's zoom in a little bit. And again, when I go zoom square, it might change this. That's a little bit worse. Yeah, that's about as good as we're gonna get. So there we have it. That is our rose with 3 petals. Notice the bottom petal is symmetric. It's gonna go around the y-axis, and the other 2 petals are kind of symmetric about the y-axis. So if we were to fold this along our y-axis, we would for sure have that symmetry there. So be mindful of that when you draw this one, okay? And let's see, we go down 2, which should kind of make sense because A was 2. All right. So we're going to go down 1, 2. So that's our first petal. And then our other petals are kind of in quadrants 1 and 3. It's not the most beautiful rose I've ever drawn. It probably actually is. But there you have it. So that is a rose. I think they're my favorite. I think they're kind of easier to graph. I like the idea of the petals. The equations aren't super crazy. So there you have it. That's a rose. All right, next up, we'll look at a lemniscate. And then we have, oh my gosh, we've only got 2 more topics left. And then we'll look at graphing 2 of these kind of like by hand without just getting a sketch from the calculator, okay?